This video is about graphing linear equations. There's two ways to graph linear equations. One way is when the equation is written in slope-intercept form. That's y equals mx plus b. In this form, it's really easy because the m stands for the slope and the b stands for the y-intercept, which is why it's called slope-intercept form. I like to think of it, however, is that the b stands for begin. It's where you begin on the y-axis. And that the slope stands for move. It's where you move after you've already begun on the y-axis. So let's take a look at this right here. The slope is 1/2. That means we're going to, we got to begin. Okay, let's start where we begin. We begin on -3 on the axis. So we're going to begin at -3. Here's our beginning point right here. Begin at -3 on y-axis. It's the y-intercept, therefore it must be on the y-axis. Okay, for the slope, this is a slope of 1/2, and that means two things. Either you're going to move up 1 and right 2, or you could also move down 1 and left 2. Now you might say, wait a minute, this is a positive slope. Isn't a positive slope supposed to go up? Well, remember the way that fractions work and division with positives and negatives. If you have a -1 over a -2, that negative cancels out and it simplifies to positive 1/2. So in terms of moving up and down and left and right, since up is positive and down is negative, right is positive and left is negative, this means 1 up and 2 right, or it could be 1 down and 2 left. And you'll see that when we graph that, that's the same line. Okay, so let's do this. Let's move up 1, right 2. So up 1 space and right 2 spaces. Up 1 space and right 2 spaces. Up 1 space and right 2 spaces. And it's a good idea to just continue making those steps, making those dots until the end of your grid. Alright, now as I said, you could also go down 1 and left 2. If we go down 1 and left 2, then that will also make points on the same line. It's a lot better if you have graph paper. Okay. So now we're going to take the line and we're going to connect all those dots, and if your graph is accurate, okay, well you can see that my graph's maybe not accurate. Alright, let's try that one again. Let's try it from this side. Probably what's happening here is I didn't space my numbers well enough so that these are actually supposed to be on there. But anyway, you can see you begin on the b, the y-intercept, and then you use the slope to move and make other points, move up and down the stairs. Okay, let's try another one that's in slope-intercept form. This one right here is also in slope-intercept form, but it's hiding something. What it's hiding is this imaginary, well not imaginary, but this invisible +0. There's nothing added onto the end in place of the b, so that means there's really a +0 that's just kind of hiding. So that means that the y-intercept is at the origin. So we're going to begin on 0 on the y-axis. Okay, so our first beginning point is on 0 on the y-axis. Then we're going to move -3. Now, isn't slope supposed to have a rise and a run? It does. It's -3, and then anytime you have a whole number, really that's over 1. So we're going to have a slope of -3 over 1, which means we're going to move either down 3, right 1, okay, down 3, right 1, or we could also move up and left. Up 3, left 1. And let's review why that is. If you have a negative 3, then that means that it could either be a negative 3 over positive 1 or a positive 3 over negative 1. Both of those are equal to negative 3 if you simplify them. But notice the negative can only go to the top or to the bottom, because if you had a negative 3 over negative 1, that simplifies to positive 3. So that's not what we're dealing with here. We need it to simplify to negative 3, so we have to have a negative divided by a positive or a positive divided by a negative. So that means down 3, right 1, or up 3, left 1. So here we go. We're going to go down 3, right 1, down another 3, right 1. But if I want to go to the left here, I'd have to go up 3, left 1, up 3, left 1. You can see that those are all on the same line. In geometry, we call that collinear. Okay, so there's our line right there. That one worked much better. Okay, let's go to the second type of equation. Now, both of these equations were in slope-intercept form, y equals mx plus b. Well, what do you do if you don't have something in slope-intercept form? If it's in standard form, that's where the x and y is on one side and then there's a number on the other. There's a different process that you have to use to graph it. One way is to rewrite the in slope-intercept form using algebra. So we start by saying I want to get the y by itself on one side of the equals because we have to solve for y in order to get it into slope-intercept form. So to solve for y means to isolate the y. So I want to isolate the y. I'm first going to subtract 2x from both sides of the equation because I'm going to isolate the y. Then bring down the equation, negative 3y equals negative 2x plus 12. That's supposed to be negative. And then now to isolate the y, we're going to divide both sides by negative 3. That cancels out the negative 3. And we have y equals, now to simplify this right here, you have to divide negative 3 into both terms. Negative into negative makes it positive, but 2/3 doesn't reduce. So we're just going to leave it as positive 2/3 x. 3 into 12 does go evenly, it's 4, and negative divided into a positive is a negative, so negative 4. Now we have this same equation written in slope-intercept form. 4 is our beginning point, negative 4 is our beginning point, so we're going to begin at negative 4. All right, that's where we begin. And then we're going to move according to the slope. We're going to move up 2, right 3, or what? Let's think about this. Up 2, right 3. Up 2, right 3. Or you could move down 2, but then we would have to go left 3. And you can see that if you went down 2 but right 3, then it wouldn't make a straight line. But if you go down 2 and left 3, somewhere over here, then it will make a straight line. Okay, let's connect that and make a line out of those. Let's see. Right there. That's a little bit bad. Here, let me try that out again. Is that any better? Kind of. Okay, now, the next way that we're going to graph this, not involving algebra, is using a little shortcut that you can use, which is using intercepts. Now, when I say using intercepts, I like to think of it as using the 0-0 table, is what I call it. The intercept table, or 0-0 table. It's where you plug in a 0 for x and you get a y value, and that gives you the y-intercept. Then you plug in a 0 for y and get an x value, that's the x-intercept. You graph those 2 points, and you only need 2 points to make a line. When we have graphs like this, we do lots of points just to make sure we get the line right. But here, technically, you only need 2 points. Okay. So the first thing you're going to do is we're going to plug in x equals 0. So in place of x, I'm going to plug in a 0, and then I'm going to solve for y. 2 times 0 is 0, and as you know, 0 minus something, it just makes it that same number, negative 3y. And then using mental math, divide both sides by negative 3, you get y equals negative 4. So that means over here we have negative 4 as the y-intercept. Now you can also do the same thing with substituting 0 for y. So if we had 2x minus 3 times 0 equals 12, that's really just 2x minus 0 equals 12 because anything times 0 is 0. If you subtract 0, it doesn't change the value, so 2x equals 12. And if you divide by 2 on both sides, you get x equals 6, which means that this point right here, 6, 0, is the x-intercept. Okay, this is the x-intercept because it has an x value, and this is the y-intercept because it has a y value. Okay, so I'm going to graph both of those points. I'm going to graph the y-intercept first. It's at -4. And then I'm going to graph the x-intercept. That's on the x-axis at 6, 0. And we only have 2 points, but that's enough for us to make the graph of a line. Oh, you know, I really should use my line maker because that's not a very nice line. There we go. Kind of. Any better? All right, well, fine. You get the idea. Okay, now I want you to take a look at this and think about, there we go. Think about how this line relates to the line from the other one. This has a y-intercept of -4 and an x-intercept of 6. Well, look back here. This one also had a y-intercept of -4 and an x-intercept of 6. We graphed the same exact line because it's the same equation. We're just using a different method. Now, do you have to do all of this mess right here? No, there's a shortcut for it. All right, the shortcut is when you're making this table, the 0, 0 table, you just take your finger. Okay, so let me just there's my finger. Okay, I know that's not really my finger, but I'm going to take my finger and I'm going to cover up part of the equation and do it mentally. If I plug in 0 for x, since I know that's just going to make it disappear, I'm going to cover that up. And I have a one-step mental math equation, -3y equals 12. Well, that's obviously what? That's obviously -4. I mean, that's mental math, right? -3 times -4 is 12. Okay, so now I'm done with that. Then I remove my finger and say, okay, if I plug in 0 for y, then this term will disappear. And I have a simple one-step equation, 2x equals 12, which I can solve mentally. It's 6. Okay, so that's easier. Do you have to go through this whole mess of having the equations and writing out equals 0? And no, you just take your finger, cover this part up, done. Now, of course, that's assuming that these two coefficients go evenly into 12. If they don't, then it's a little bit harder. But this is what I would recommend, is just covering up each part, making the table, and then graphing the table. You don't even have to worry about this stuff here. Okay, the last thing is graphing horizontal and vertical lines. These are special because these only have x or y and not both. Now, a horizontal line is y equals something, all right, and it doesn't have an x. A vertical line has only x, it doesn't have a y. Now you might say, wait a minute, that doesn't make sense. I mean, look right here at the graph. The x-axis is horizontal, not vertical. The y-axis is vertical, not horizontal. So how does this work? Well, think about it. In order for it to be horizontal, it has to slice through the y, but never slice through the x. Because if it's horizontal, it's going to be parallel to the x-axis. So it can't have an x in it because it can never go through the x. So the way that you graph this is this tells you that on the y-axis there's a -3. So we graph -3 on the y-axis, and it's a horizontal line because it will never go through the x-axis. So we draw a horizontal line, and then if it's not right, then you move it. There we go. Okay. This is a horizontal line. It'll never intersect the x-axis, therefore the equation doesn't have an x in it. Now if we go over to the vertical line right here, this means to be vertical it has to be parallel to the y, so it can never go through the y. So there can't be a y in the equation, only an x, because if it's vertical it will slice through the x-axis, and this one slices through the x-axis at 2. So once you graph the intercept, then you just make your line. Then it's going to go vertically through that number. So that's how you graph horizontal and vertical lines. Hope that helped.